we are going to discuss about the quantum numbers. Now we know that in an atom there are number of the atomic orbitals which are permissible. Now this atomic orbitals is the consequence of the Schrödinger wave equation, right? And the Heisenberg uncertainty principle, which states that the probability, that is the region where the chances of getting an electron is maximum. So the probability of getting an electron just far away from the nucleus will be also there, though it will be minimum. So quantum number, these are the set of the numbers which are being given to the permissible atomic orbitals, right? So this set of numbers we are having three set of numbers which are going to define the atomic orbitals, right? Now these set of numbers are the principal quantum numbers, these are the azimuthal or the subsidiary quantum number, and third is the magnetic quantum number. Now to define the electron, right, to define the electron, we have got the spin quantum number, which will tell us about the spin of the electron, whether it is moving clockwise and the anti-clockwise. So we are going to discuss them one by one. So let's start with the principal quantum number. Now, the principal quantum number tell us about the energy level of the electron in an atom, right? So we'll begin with the principal quantum number. So quantum numbers, they are a set of the numbers which just helps to locate the electron in an atom. So we have got the first quantum number, which is the principal quantum number, denoted by small n, and it designates the energy level, right, of permissible atomic orbital, right? So it will be the energy of that electron also which will be present in this atomic orbital, right? So it is denoting the energy level. So n denotes us about the energy level, or we can say it denotes the shell number, right? So if we have got, this is the n value, right? If n equals to 1, it will denote the k shell, right? In the same way, if it is 2, it will be L shell. If n equals to 3, it will be M shell, right? And it will go on in the same way. N equals to 4, N shell will be there. So as the shell number increases, right? If it is n equal to 1, then it is 2, 3, 4, and so on. Right here, 1, 2, 3, 4. They're denoting the principal quantum number, that is the energy level. So the electron or the atomic orbital which is just near to the nucleus, which is shell number 1, it will have the lowest energy, and it will proceed, it will start increasing with increase in the principal quantum number, right? So with increase in n value, energy level increases, right? This is the first quantum number which designate the energy level or the shell number of an atomic orbital. Now second is the azimuthal quantum number, which is denoted by small l, and the azimuthal quantum number is also known as subsidiary quantum number or orbital angular quantum number, right? Now azimuthal quantum number, it will denote denotes the shape of atomic orbital or the orbital or the angular momentum right of the electron, right. It also indicates the subshell in which electron will be present. So these information are given by the azimuthal quantum number, right. For every shell, that is, let it be n equals to 1. For every shell, right, we will be having the subshell. Now let it be n equals to 1 first shell, then the number of the subshell, which is denoted by L, will be equal to 0 to n, right. That means if it is first shell, we will have 0 to 0. That means only one subshell will be possible. That is L equal to 1, right. Now this shell, that is n equals to 1, it will be denoted by S. Now let us first do this one. N equals to 2. If it is shell number 2, that time the possible values for L, that is subshell, will be from 0 to n. That is 0 to, it is how much? Sorry, this is 0 to n minus 1 here. Right, so 0 minus 1, it will come 0 only, nothing will be left. So it is 0 to 2 minus 1, that is we will having 0 to 1. So we will have the two values here. It will start from 0 and it will be 1, right. So this is there, that is L equal to 0. 0 means here, it doesn't designate here the value 0, but it denotes the number here, right. And the 0 designate the S subshell. Now let me introduce this there, S subshell, right. Now similarly again for the second shell, we are having 0 and 1. So 0 will indicate the S subshell and 1 will indicate the P subshell. So this is S subshell and this is the P subshell, right. Now n equals to 3. So students, what are the possible values? It will be 0 to n minus 1, that is 0 to n minus 1, that is 3 minus 1. So how much it will come? 0, 1 and 2. 0 to 2. So 0, 1 and 2. What does 0 indicates here? S. So this is S subshell. 1 is indicating the P subshell and 2 is indicating the D subshell. Right? These all subshells S, P, D will be written in the small letters. Now n equals to 4. So it will be 0 to n minus 1, that is 4 minus 1. So how many values we will get here? 0, 1, 2 and 3. Now what is 0 here? Denoting S. This is P subshell. This is D subshell. This is H subshell. Right students? So for every subshell, for every shell, we will have the subshell linked to it. Right? And you can see here one thing, that the number of the subshell is equal to the shell number. Right? For first shell number is 1. So for it we will have only one subshell. It is S subshell. For n equal to 2, right, we will have how many subshell? 2 subshell. 0 and 1, that is S and P. For n equal to 3, we will have how many subshell? 3 subshell. What are they? 0, 1 and 2, that is S, P, D, and n equal to 4, we will have 4 subshells S, P, D and F, right? Now these subshells just tell us about the shape of the atomic orbital. Azimuthal quantum number here. So azimuthal quantum number give us the shape of the atomic orbitals in which the electrons are present, right? So we have come to know that for the every shell value is n value, we will have the same number of the subshell associated with it, right? Now here you can see that if the value of L is 0, right, then the subshell which is designated by small s, then if it is 1 it will be small p, then 2 it will be d, 3 it will be f, 4 it is g, 5 it is h, and 6 it is I. You can see here that all the letters are in small, so don't forget to write them in small letters, right? And you have to learn this, that whenever it is written 0, it will be S subshell, or whenever it is written here that asked you it is a P. So P subshell is going to denote the subshell value 1, right? The same way D is going to denote the subshell value 2, L value 2. Or if it is written 3, it will denote F, right? If it is written 2, it will denote D, 1, P and 0 S. Right? Now, by knowing the value of L, we can find out the orbital angular momentum. That's why this quantum number is also known as orbital angular momentum, orbital angular quantum number. So it is under root L, L plus 1, H upon 2 pi. So by knowing the value of L, right, that is the electron's subshell value, we can find out the or angular momentum which will be associated with it when it is moving that particular subshell. Now next we will do about the magnetic quantum number. Now next is the magnetic quantum number denoted by M subscript L. So the magnetic quantum number tell us about the orientation of atomic orbital, right? Now you will see here very properly here. Now I'm just going to do here if n equals to 1, right? If first shell we are having, so how many subshells will be associated with it? 0 to n minus 1, that is only 1 subshell. Now this 0 is indicating not the magnitude, that its value is 0, but it is indicating the only one subshell, that is S subshell, right? So here we will be having the subshell value, that is L, and here we will have the ml value which will tell us about the atomic orbitals which will be associated, right? So for every subshell, the number of the orientation or the number of the atomic orbital which will be related to it will be from minus L to plus L, right? This is there, minus L to plus L. Definitely 0 will be also there. So it is 0. So what are the possible values? It is minus 0, then 0 and plus 0. Now student, all these are indicating only one value, that is 0. So for first shell we have only one subshell S and only one orbital, that is S orbital. So number of orbital is how many? 1. Right? Now come to second one, n equal to 2. Now how many possible subshell values are there? It is how much? 2. That is 0 and 1. Right? 0 and 1. This is S subshell. This is P subshell. Now for every 0, For every subshell we will have one atomic orbital associated with it. For 0 we have only one atomic orbital, but for 1 we are having from minus L to plus L, that is from minus 1, then it will be 0, then it will be plus 1. So students, for a shell number 2, we are having how many subshell? We are having 2 subshell. This is S subshell, this is P subshell. This 0 is indicating the S, right? So it is a S subshell here, and this is the P subshell here. Now for every S subshell, we will have only one S orbital. There will be only one S orbital, and how many orbitals for the P subshell we will be having? We will be having 3 values of p orbitals, right? So number of the, we can say, p orbitals are how many? It is 3, right? Now these 3 orbitals are the p orbitals, which is px. The orbital which is lying on the x-axis, it is px, right? And then py and pz axis, pz, right? The 3 orbitals are possible. For p orbital will be possible for when we have subshell 1, only p subshell, right? So in total, how many orbitals are there in S subshell, S cell, right? We can say the second shell, how many orbitals are there? The 3 of p and 1 of S. So total we are having how many? 4, right? Now we will just move ahead. We will do for n equals to 3 now. Now, if we have got shell number 3, right, what are the possible values of the subshell? It is 0, it is 1, it is 2. S subshell, P subshell and D subshell. Now, for every S subshell, we have only one S orbital, 0. For every P subshell, we have only 3 p orbitals. So I am writing here -1, 0 and +1. Right? This is 3 orbitals. Now the second subshell. Right? For second subshell, how many possible values will be there? It will be -2. Right? It will be how much? Then -1. It will be 0, +1 and +2. That is from negative to positive value of the L. So how many are there? 1, 2, 3, 4, 5. That means for the second subshell, we are having how many values for the orbitals? It is, for second subshell, it is how much? It is 5. Right. So in total, how many orbitals are there in the third shell? 1 for this is 3 and this is 5. So total we are having here 9 orbitals. Right, students? So 0 will indicate, again I am telling, 0 indicates the S, 1 indicate the P and 2 indicate the D. Now a question can come in your mind that what does the S indicate, what does the P indicate, D and F, right? What does the full form of it, or we can say what is going to be indicated here. So here the S is indicating, or it means sharp is related with the spectral lines or spectral studies, right? S, P indicate the principal, D is indicating the diffused, and F is indicating the fundamental. Right, students? These S, P, D and F, which we are using for the subshell also and we are using for the orbital also, they indicate this. S is indicating sharp, P is indicating principal, D is diffuse and F is fundamental. So students, we have done the magnetic quantum number. Now the fourth quantum number, which is associated with the electron, is the spin quantum number. This is the quantum number which is related with the spin of the electron, whether it is spinning clockwise or anti-clockwise, right? So next is the spin quantum number denoted by ms. Now you know that an electron, this is indicated electron, right? Now this is its axis of rotation. Now what are the possible ways it can rotate? It can either rotate clockwise, right? So how many possible orientations are there? It is total 2. Either it can rotate clockwise or it can rotate anti-clockwise. This is the clockwise, and if we say this is going in this way, it is the anti-clockwise. Now when how many possible outcomes are there? There are two possible outcomes. So when it is moving clockwise, it is out of total 2, it is only one possible value which will get, that is half, right? Now this is toward the clockwise, we are going to denote it with plus, and here again this will be half, but it will be denoted by the minus sign, right? So this is the clockwise and this is anti-clockwise. So the possible spin of the electrons are plus half and minus half, right? So in an orbital, right, we have studied from shell, then we come to subshell, and then we are coming to orbital. That is the electrons probability of finding getting maximum we can indicate through its orbital. Right. Now, how many electrons are possible in an orbital? It is only two. One will be having the clockwise spin and another will be having the anti-clockwise spin. Now, students, you should keep in mind this one also. Generally, we denote the orbital with the square box, or you can draw it in a circle also. So, in an orbital, right, the electron with the spin clockwise is shown in this way, and in the anti-clockwise it is in this way. We can have we can either have no electron, empty orbital, or we can have one electron in the orbital, and we can have two electrons, but we can't exceed to 3, right? For third electron to get accommodated, we have to move to the another orbital. So in an orbital, we can have only two electrons because we are having only two possible spin of an electron, that is clockwise and the anti-clockwise, right? So here we have completed the quantum numbers. So quantum numbers designates or help us to locate the position of an electron in an atom. To locate the position of an electron in an atom, we have got three quantum number. First is a principal quantum number showing the shell number, indicating the shell number or the energy level. Then we have got the azimuthal or subsidiary quantum number, which indicates the subshell, or we can say the shape of the uh, region where the electrons will be present. Then comes we have got the next is the magnetic quantum number, which indicates the orientation, right, of the atomic of the region, or we can say of the atomic orbitals. Now the third last one, the spin quantum number, is mainly related with the electron, that in an orbital how many electrons are there? Only two. One is this related with the clockwise spin and the anti-clockwise, so we will have only two electrons possible in an orbital.